I am Mark, virtual teacher instructor at Egnatia Career College. Today we'll teach locating the building, site utilities, footings, and foundation walls. This is video number 3. Part 2. Reading drawings, lake house. In Part 2, you will examine all the information necessary to build a moderately complex single-family home. The sequence of the units in Part 2 follows the sequence of actual construction. In some cases, all the information necessary for a particular stage of construction can be found on one sheet of drawings. Other stages require cross-referencing among several drawings. The relationships among the various drawings are discussed as the need to cross-reference them arises. This lake house was designed as a vacation home on a lake. The design is moderately complex, involving several floor levels and some interesting construction techniques. Clearing and rough grading the site. After completing this unit, you will be able to perform the following tasks. Identify work to be included in clearing a building site according to site plans. Interpret contour lines and grading indications on a site plan. Interpolate unspecified site elevations. Property boundary lines. The boundary lines of the building site are shown on the site plan. The direction of a property line is usually expressed as a bearing angle. The bearing of a line is the angle between the line and north or south. Bearing angles are measured from north or south depending on which keeps the bearing under 90 degrees. Angles are expressed in degrees, minutes, and seconds. There are 360 degrees in a complete circle, 60 minutes in a degree, and 60 seconds in a minute. The point of beginning may or may not be shown on the site plan. If the point of beginning is not shown on the plan, start at a convenient corner. Corners are usually marked with a pin, IP, or some permanent feature. The approximate direction of the boundaries can be found with a handheld compass. This approximation should be accurate enough to aid in finding the marker at the next corner. Proceed around the perimeter in this manner to find all corners. All construction activity and debris should be kept within the property boundaries unless permission is first obtained from neighboring landowners. Clearing the site. The first step in actual construction is to prepare the site. This means clearing any brush or trees that are not to be part of the finished landscape. The architect's choice of trees to remain is based on consideration of many factors. Trees and other natural features can be an important part of architecture not only for their natural beauty, but for energy conservation. Deciduous trees, which lose their leaves in the winter, can be used to effectively control the solar energy striking a house during warmer months where the trees shade the south side of the house. In the winter, the sun shines through the deciduous trees on the south side of a house, thus taking advantage of this source of heat. The lake house in your drawing package offers a good example of the importance of the selection of trees to remain on a site. This house gets a large part of its heat from its passive solar features, which are described more fully later. Trees that are to be saved are shown on the plot plan by a symbol and a note indicating their diameter and species. Areas that are too densely wooded to show individual trees are outlined and marked woods. Removal of unwanted trees may require felling and stump removal, or may be accomplished with a bulldozer and dump truck. In either case, care must be exercised not to damage the trees that are to be saved. Grading. Grading refers to moving earth away from high areas and into low areas. Site grading is necessary to ensure that water drains away from the building properly and does not puddle or run into the building. In some cases, grading may be necessary for access to the site. For example, if the site has a steep grade, it may be necessary to provide a more gradual slope for a driveway. Grade is measured in vertical feet from sea level or from a fixed object such as a manhole cover. This vertical distance is called elevation. The term elevation to denote a vertical position should not be confused with elevation drawings that show the height of objects. The elevations of specific points are given as spot elevations. Spot elevations are used to establish points in a driveway, a walk, or the slope of a terrace. Spot elevations are often given for trees that are to be saved. The grade of a site is shown by topographic contour lines. These are lines following a particular elevation. The vertical difference between contour lines is the vertical contour interval. For plot plans, this is usually 1 or 2 feet. When the land slopes steeply, the contour lines are closely spaced. When the slope is gradual, the contour lines are more widely spaced. The builder must be concerned with not only the grade or contour of the existing site, but also that of the finished site. To show both contours, 2 sets of contour lines are included on the plot plan. Broken lines indicate natural grade, NG, and solid lines indicate finished grade, FG. When the natural grade elevation is higher than the finished grade elevation, earth must be removed. This is referred to as cut. When the natural grade is at a lower elevation than the finished grade, fill is required. To determine the amount of cut or fill required at a given point, find the difference between the natural grade and the finished grade. Interpolating elevations. Sometimes it is necessary to find an elevation that falls between 2 contour lines. This can be done by interpolation. Interpolation is a method of finding an unknown value by comparing it with known values. To interpolate the elevation of the tree at point A, follow the steps. Step 1. Scale the distance between the 2 adjacent contour lines, 12 feet. Step 2. Scale the distance from the unknown point to the nearest contour line, 4 feet. Step 3. Multiply the contour interval by the fraction of the distance between the contour lines to the unknown point. Step 4. If the nearest contour line is below the other one, add this to it. If the nearest contour line is above the other one, subtract this amount. Locating the building. After completing this unit, you will be able to perform the following tasks. Lay out building lines according to a site plan. Use the 6, 8, 10 or equal diagonals method to check the squareness of corners. Use a laser level to measure the depths of excavations. Laying out building lines. The position of the building is shown on the site plan. Dimensions show the distance from the street or lake to the building and from the side boundaries to the building. The location of one corner can easily be found by measuring with a long steel tape. The lot boundaries are represented by A, B, C, and D. Along boundary line A to C, measure the distance from the front edge of the property, usually a street. Mark this point with a stake, E. As you drive each stake, drive a nail in the top of the stake to accurately mark the location. Measure the same distance along the other side boundary, B to D, and mark that point with stake F. Stretch a string from stake E to stake F. The front of the building will fall on this string. The distance from the front boundary to the building line is called the front setback. Both the front and side setbacks are nearly always regulated by zoning ordinances. Next, measure the side setback, which is the distance from the side of the property to the side of the building at stake E to side of the building, line EG. Drive a stake where the side setback and front setback meet. This stake represents one front corner of the building, corner G. Find the other front corner by measuring the width of the building from the first corner, line G to H. Check the distance from the corners to the front boundary of the lot to make sure it agrees with the setback shown on the site plan. Now measure the depth of the building from the front corners to the rear of the building, corner I. Use a framing square to make corner G as square as possible. Check the corner for square using the 6, 8, 10 method. Measure 6 feet from the corner along line G to I to find point A. Measure 8 feet from the corner along line G to find point B. Line A to B should be exactly 10 feet. Adjust the angle of the side building line as necessary to make AB 10 feet. Drive a stake at corner I. Repeat the process to find the other rear corner J. Check to see that the rear building line, IJ, is the dimension shown on the plans. Make adjustments as necessary until all corners are square and all dimensions are correct. Now check the final layout. Ensure that rectangles have 90-degree corners by measuring the diagonals. When the diagonals are equal, the corners of the rectangle are square. The building lines can be saved, even after the corner stakes are removed for earthwork, by erecting batter boards. Batter boards are sturdy horizontal boards fastened between 2x4 stakes, at least 4 feet outside the building lines. The building lines are extended and marked on the batter boards. Excavating. Most buildings require some excavation, digging, to prepare the site for a foundation. The depth of the excavation is measured from a fixed benchmark. A benchmark can be any stationary object, such as a surveyed point on a street or very large boulder that cannot be moved. All elevations, vertical distances, are measured from this benchmark. Only in the case of a real coincidence would the benchmark be at the same elevation as the surface of the ground where the excavation is to be done. The actual depth of the excavation is the difference between the elevation at the surface of the ground and the elevation at the bottom of the excavation. Concrete footings. Concrete footings are placed in the bottom of the excavation to support the entire weight of the building. These footings are placed on unexcavated earth to reduce the chance of the soil compacting under them. This means that the excavation contractor must measure the depth of the excavation accurately. The footings may be stepped to accommodate a sloping site. This requires measuring the depth at each step of the footing. Information about the footing design is found on the foundation plan and building elevations. The layout of the foundation walls and their footings is shown on the foundation plan. If the footing size is not indicated on the foundation plan, a consulting engineer will have to determine the size in accordance with the local building code and the conditions at the site. The depth of the foundation, including its footing, is shown on the elevations. To simplify calculating excavation depths, many architects indicate the elevations as key points along the footings. A section view through all or part of the building may show a typical depth, but it is wise to check all the elevations for steps in the footing. The footings may be shown on the elevation as a double or a single dotted line. In masonry foundations, steps in footings are usually in increments of 8 inches to conform to standard concrete block sizes. A laser level is often used to measure elevations and depths of excavations. Setting up a laser level is similar to setting up a builder's level. You should follow the manufacturer's instructions and obey the safety precautions provided for the use of the laser level. Use the following procedure to measure differences in elevation, such as the depth of an excavation. Step 1. Set the instrument up on a tripod and level it in a convenient location. Step 2. Hold the target rod on a known elevation, such as a benchmark or ground of known elevation. Note the reading on the target rod where the target registers the laser beam. Step 3. Take a similar reading with the target rod at the bottom of the excavation. Site utilities. After completing this unit, you will be able to perform the following tasks. Interpret symbols and notes used to describe site utilities. Explain the septic system indicated on a site plan. Determine the pitch of drain lines. In some cases, sewers may have to flow uphill. Uphill flow is accomplished by a grinder pump. A grinder pump grinds solids into small enough particles to be pumped and pumps the sewage at low pressure. Building sewer. Any plumbing that is to be concealed by concrete work must be installed without fixtures or roughed in before the concrete is placed. Because the plumbing contractor installs all plumbing inside the building lines, this phase of construction is discussed later with mechanical systems. The sewer, however, is usually installed after the building is erected to prevent damage due to machinery on the site during construction. The sewer, too, is generally considered a site utility, which is why it is discussed here. The workers who install the sewer must be able to determine the elevation at which it passes through the foundation and the pitch of the line outside the building. The sewer line may be shown on plans as a solid or broken line. Although it is usually labeled, this is not always true. When the sewer is not labeled as such, it can still be recognized by its material, pitch, and ending place. In light construction, the sewer is usually the only 4-inch pipe to the building. Also, the sewer is the only line with the pitch indicated. Municipal sewers and septic systems. In most developed areas, the building sewer empties into a municipal sewer line near the street. The contractor for the new building is responsible for everything from the municipal sewer to the house. In less developed areas, the sewer carries the sewage to a septic system. The most common type of septic system includes a septic tank and drain field. The septic tank holds the solid waste while it is decomposed by bacterial action. The liquids pass through the baffles and flow out of the tank to the distribution box. The distribution box, DB, diverts the liquid into leach lines. These perforated plastic or loose-fitting tile lines allow the liquid to be absorbed by the surrounding soil. The liquid gradually evaporates from or drains through the soil. The drain field, where the leach lines are laid, is usually made of a layer of crushed stone. The design of septic systems is closely regulated by most health and plumbing codes. These local codes should be checked before designing or installing any septic system. The building code or health department code often requires a percolation test before the system can be approved. In a percolation test, holes are dug. Then a measured amount of water is poured into each hole. The amount of time required for the water to drain into the soil is an indication of how well the soil will accept water from the septic system. This ability to accept water is called percolation. The locations of key elements in the system are often shown on the site plan. To ensure proper drainage for a septic system, the elevation of its drainage piping is critical. For this reason, it is necessary to know the invert elevation of a pipe, which is the elevation at the lowest point inside the pipe. Other piping. Other utility piping, such as that for water supply or gas, is shown on the site plan. If these lines will pass beneath the concrete footings or be concealed under a concrete slab, they must be roughed in before the concrete is placed. Water supply pipes follow the most direct route from the municipal water main or well to the main shutoff valve or pump. Gas lines run from the main to the gas meter. All supply lines on the plot plan should be labeled according to type and size of piping. Electrical service. The electrical service is the wiring that brings electricity to the house. There are two types of electrical service: overhead and underground or buried. Overhead service involves a cable from the utility company transformer or pole to a weather-tight fixture called a service head or mast head on the house. The service head is mounted on the top of a pipe, which serves as a conduit to the meter receptacle. In an underground service, the cable is buried. Although electrical service is a site utility, it is not usually installed until the building is enclosed. The electrical service to residential and small commercial buildings is similar, as explained in this picture. This type of service has only one distribution point, the main electrical panel. Heavy commercial and industrial electrical services require multi-conductor feeders, and typically these are underground services from a utility transformer to a service entrance section in the designated electrical or utility room. Additional utility coordination will be required within the building. The placement of these underground electrical utility lines must be coordinated with the locations of other site and building utilities prior to starting installation. Footings. After completing this unit, you will be able to perform the following tasks. Find all information on a set of drawings pertaining to footing design. Interpret drawings for stepped footings used to accommodate changes in elevation. Discuss applicable building codes pertaining to footing design. All soil changes shape under force. When the tremendous weight of a building is placed on soil, the soil tends to compress under the foundation walls and allow the building to settle. To prevent settling, concrete footings are used to spread the weight of the building over more area. The footings distribute the weight of the building so that there is less force per square foot of area. The simplest type of footing used in residential construction is referred to as slab-on-grade. In this system, the main floor of the building is a single concrete slab, reinforced with steel to prevent cracking. The walls are erected on this slab so that it supports the weight of the building. Slab-on-grade foundations are common in warm climates. This type of construction is indicated on the floor plan by a note and on section views of the construction. If excavation is involved in the construction where a slab-on-grade is to be placed, it is very important to thoroughly compact all loose fill before placing the concrete. Tamping the fill prevents the soil from compacting under the concrete later, causing the concrete to settle or crack. A thickened slab, sometimes called a haunch, is used to further strengthen the slab where concentrated weight, such as a bearing wall, will be located. A haunch is an extra thick portion of the slab that is made by ditching the earth before the concrete is placed. Spread footings. In most sections of the country, the foundation of the house rests on a footing separate from the concrete floor. This separate concrete footing is called a spread footing because it spreads the force of the foundation wall over a wider area. Spread footings can be made by placing concrete inside wooden or metal forms. The footing is shown on the foundation or basement plan by dotted lines outside the foundation wall lines. The dimensions of the footings can be determined from the dimensions shown for the foundation. The foundation rests on the center of the footing unless otherwise specified, but the dimensions must meet the minimum requirements. If an 8-inch foundation rests on a 16-inch footing, the footing projects 4 inches beyond the foundation on each side. To lay out these footing lines, measure 4 inches from the building lines marked on the batter boards. Where footing lines cross to form a corner, suspend a plumb bob. Drive a stake under the plumb bob. Then, drive a nail in the stake to accurately mark the corner. When all corners are located in this manner, stretch a line between the nails to locate the inside of the footing forms. A complete set of construction drawings also includes sections that show the spread footing in greater detail. However, these drawings are often superseded by local building codes. Building codes for footings include such things as minimum permissible depth of footing, required strength of concrete for footings, the width of footings, and the use of keys or dowels made of reinforcing steel. Column pads. Where steel columns, masonry piers, and wooden posts are used in the construction, a special concrete pad is indicated on the foundation plan. As with other footings, building codes for the area should be consulted for the design of these pads. These pads, as with all other footings, should rest on unexcavated or well-compacted earth. Reinforcement. Footings, column pads, and other structural concrete frequently include steel reinforcement. Footing reinforcement is normally in the form of steel reinforcement bars, commonly called rebars. Reinforcement bars are designated by their diameters in eighths of an inch. Depth of footings. In many sections of North America, the moisture in the surface of the earth freezes in the winter. As this frost forms, it causes the earth to expand. The force of this expansion is so great that if the earth under the footing of a building is allowed to freeze, it either cracks the footing or moves the building. To eliminate this problem, the footing is always placed below the depth of any possible freezing. This depth is called the frost line. The local building department will have specific footing depth requirements for their area. Two methods are commonly used to indicate the elevation or depth of the bottom of the footings. The easiest to interpret is for spot elevations to be given at key points on the elevation drawings. Where elevations are given in this manner, the tops of the footing forms are leveled with a leveling instrument using a benchmark for reference. Another commonly used method is to dimension the bottom of the footing from a point of known elevation. This may be the finished floor or the top of the masonry foundation. These dimensions are given on the building elevations. Stepped footings. On sloping building sites, it is necessary to change the depth of the footings to accommodate the slope. This is done by stepping the footings. When concrete blocks are to be used for the foundation walls, these steps are normally in increments of 8 inches. This allows the concrete blocks to be laid so that the top of each footing step is even with a masonry course. Some buildings require several steps in the footing to accommodate steeply sloping sites. Steps in the footings are shown on the elevation drawings and on the foundation plan by a single line across the footing. This house has several steps in the footing. For example, see the east side of the garage. This is shown on the east elevation 2 to 3rd. This step is also shown on the foundation plan. It is 8 feet 0 inch from the north end of the garage. Normally the two levels of the footing should overlap each other. The stepped footing shown on the east elevation does not appear to overlap. Foundation walls. After completing this unit, you will be able to perform the following tasks. Determine the locations and dimensions of foundation walls indicated on a set of drawings. Describe special features indicated for the foundation on a set of drawings. Laying out the foundation. When the concrete for the footings has hardened and the forms are removed, carpenters can begin erecting forms for concrete foundations, or masons can begin laying blocks or bricks for masonry foundations. Although the material differs, the drawings and their interpretation for each type of foundation are similar. The outside surface of the foundation wall is laid out using previously constructed batter boards. Then the forms are erected or the masonry units are laid to these lines. The foundation plan includes overall dimensions, dimensions to interior corners and special constructions, and dimensions of special smaller features. It is customary to place the smallest dimensions closest to the drawing. The overall dimensions are placed around the outside of the drawing. All drawing sets include, at least, a wall section showing how the foundation is built, how it is secured to the footings, and any special construction at the top of the foundation wall. Although a typical wall section may indicate the thickness of the foundation wall, you should carefully check around the entire wall on the foundation plan to find any notes that indicate varying thicknesses of the foundation wall. For example, the wall may be 12 inches thick where it has to support brick veneer above, while it is only 8 inches thick on the back of the building where there is no brick veneer. A careful check of the foundation plan for this house shows that the house foundation is 10-inch thick concrete, except the portion under the fireplace, which is 12 inches thick. Some portions of the foundation wall have 6-inch concrete masonry units at the top to create a ledge for special construction, and the garage foundation calls for 8-inch concrete. Structural concrete is the most common foundation material because it is strong and concrete foundations can be built quickly. Some buildings have masonry, usually concrete block foundations. There are some additional topics to be discussed for masonry, concrete block foundations. The details for a masonry foundation may call for horizontal reinforcement in every second or third course. This is usually prefabricated wire reinforcement to be embedded in the mortar joints. Prefabricated wire reinforcement is available in varying sizes for different sizes of concrete blocks. The height of the foundation wall is dimensioned on the building elevations. These are the same dimensions as of those used to determine the depth of the footings in the preceding unit. Just as the footing was stepped to accommodate a sloping building site, the top of the foundation wall may be stepped to accommodate varying floor levels in the superstructure, construction above the foundation, as shown in. The top of a foundation may be built with smaller concrete blocks to form a ledge upon which later brickwork will be built. It is also common practice to use one course of 4-inch solid block as the top course of a masonry foundation wall. In concrete foundations, anchor bolts are placed in the top of the foundation. These bolts are left protruding out of the top of the foundation so that the wood superstructure can be fastened in place later. Anchor bolts are not normally shown on the foundation plan, but a note on the wall section indicates their spacing. On masonry walls, anchor bolts can be placed in the hollow cores of the concrete blocks. They are held in place by filling the core with mortar grout. Grout is a Portland cement mixture that has high strength. In areas where there is a threat of extremely high winds or earthquakes, additional hold-down straps may be called for. These hold-downs are normally used only with concrete foundations. Special features. Many foundations include steel or wooden beams, which act as girders to support the floor framing over long spans. When the girder is steel, it is indicated by a single line with a note specifying the size and type of structural steel. A wood girder is usually indicated by 2 or more lines, and a note specifying the number of pieces of wood and their sizes in a built-up girder. If the top of the girder is to be flush with the top of the foundation beam, pockets must be provided in the foundation. Beam pockets are shown on the details and sections of the construction drawings. The locations of these beam pockets are dimensioned on the foundation plans. If windows are to be included in the foundation, the form carpenter or mason must provide openings of the proper size. The locations of windows should be dimensioned on the foundation plan. The sizes of the windows may be shown by a note or given on the window schedule. It is important, however, to get the masonry opening size from the window manufacturer before forming the opening in the foundation wall. The masonry opening is the size of the opening required in the foundation wall to accommodate the window. This size may be different from the nominal size given in a note on the foundation plan. The foundation may include pilasters for extra support. A pilaster is a thickened section of the foundation, which helps it resist the pressure exerted by the earth on the outside. The location and size of pilasters are shown on the foundation plan. Permanent wood foundation. Foundations are usually constructed of concrete or concrete block. However, a type of specially treated wood foundation is sometimes used. These permanent wood foundations do not use concrete footings. Instead, they are built on 2x8s or laid on gravel fill below the frost line. The foundation walls are framed with lumber that has been pressure treated to make it rot resistant and insect resistant. The framing is covered with a plywood skin, and the plywood is covered with polyethylene film for complete moisture proofing. All the nails in a wood foundation are stainless steel to prevent rusting. The IRC includes separate provisions to cover wood foundations.